Hello.
Hello, yes, sir.
Yeah. So we'll continue trigonometry. How much have you attempted? Have you tried the questions that you were supposed to do?
Sir, I wasn't able to complete all of it, especially because I had Alan like 3 weeks of
That is
work
not
to
a
catch him.
legitimate excuse. But yeah, tell me how much have you attempted? See, I
So
had Alan is not legitimate. Okay.
yes, I won't happen again.
I mean, don't say I have Alan. Okay, whatever. I don't care about Alan, dude. You should also not care because we are going to be far ahead of Alan soon. So you cannot say that we are doing some chapter 10 and Alan is doing chapter 1 and so I couldn't do chapter 10 homework. Okay.
Yes.
So first time, so it's fine. I don't expect you to finish all the problems, but I hope you tried. There were some 3 exercises that we had to attempt, right?
Yes, sir.
So you tried some questions, right? From all of them.
Yes, sir. Yes.
Okay, so tell me any doubts, any problems, everything.
So the 14th one from the first exercise.
Which
Examples
exercise?
5.
Which examples 5? 14th one. Okay. So this tan by cot and all, right? Tan A
So
by
I
1.
converted it to sine and cos, but I got some weird answers.
So 1 second. Tan A by 1 minus cot A plus cot A by 1 minus tan A is equal to, you have to prove that sec A cos A, sec A cosec A plus 1. Okay. Fine. This is something that you have to prove. Now, obviously, like it is more convenient to work in sine and cos. Okay. So I will just work in sine and cos. So this is sine A by cos A and 1 minus cos A by sine A, right? Plus this is cos A by sine A, 1 minus cos sine A by cos A, right?
Yes, sir.
So just take the numerator here, sine A minus cos A by sine A. So you will get, after you simplify a little bit, you will get sine square A by cos A, sine A minus cos A, plus you will get cos square A by sine A, cos A minus sine A, right? Correct.
Yes.
You're getting this. So obviously I can take common factor here, right? So 1 by sine A minus cos A is my common factor. So then you end up getting sine square A by cos A minus cos square A by sine A, right? Because here the factor was cos A minus sine A, so I've taken sine A minus cos A, so minus sine, right?
Yes, yes.
So this will become sine cube A minus cos cube A, and I can see the question is over, dude. Question is over, can you see?
Yes, sir.
So don't tell me that this was beyond your abilities, okay? Right? This is some careless mistake that you are doing, right?
Yes.
Because this is like straightforward stuff. Have I done anything unusual? I've not done anything here. Just converted and taken common. And now I'll cancel one factor from here. And this will become sine square A plus sine A cos A plus cos square A, right?
Yes, sir.
And sine square plus cos square is 1. So it is 1 plus sine A cos A by sine A cos A. That is simply 1 plus sec A cosec A. Right?
Yes, sir.
So where did you get stuck? What did you do?
I think my minus and plus signs were in the till before sine cube A minus cos cube A. The
You
step
did
before that.
if you did plus here, then it will be wrong, obviously. Then it will not come. You have to see that the factors here are not the same. So if you have to minus, you have to take out, right?
Yes, sir.
So that is just a silly mistake, because if you get plus there, then the factors will not cancel. Downstairs it will be sine A minus cos A, upstairs it will be sine A plus cos A, right? A cube plus B cube will not cancel with this one, right?
Yes.
Okay. Next one. What is the next one? Next problem.
I didn't spend enough time on this, but the 26th one.
26th one. Okay. Why didn't you spend enough time on it? You didn't have enough time, okay?
Yes,
You're
sir. I was
running out
trying to
of
do like
time.
more questions.
But yeah, but see, what we will be doing is more important than whatever else you have going on. Okay. So
Yes.
what are they doing in Allen right now?
In maths?
Huh?
In maths, they're doing complex numbers.
What the hell is happening? Why are they doing complex numbers right now? Complex numbers they're doing.
Yes, sir.
This is part of that basic maths chapter, okay?
So I think they're doing a few chapters early because the proper batch starts from like June. So they're just covering like a few chapters earlier. So I guess it's easier for them later.
I would advise you to ignore whatever is going on there, because complex numbers you cannot be taught right now. No, you don't know any trigonometry, you don't know nothing. How will you learn complex numbers? What are they teaching right now in complex numbers? I is equal to root minus 1 and manipulate I cube and all. That's all. No?
So they were doing argument and all.
They are proper. They are properly doing the whole chapter at this stage. That's great. So the planning process at Allen is a little under doubt here, because you cannot start the first chapter in 11th as complex numbers. Okay. Because right now you don't know trigonometry also.
Yes, sir.
Have they done trigonometry?
So for us, they've done, but like that was last year, not this year.
So basically they have assumed that everyone who has come to that class right now remembers all the trigonometry from the beginning of 10th standard. And then therefore they have started complex numbers, right? So
Yeah, basically.
please don't pay attention to that, because I don't want you to be confused by stuff in complex numbers. Okay. Complex numbers is a difficult and very important chapter, and it you need to give it the due respect, right? Like you need to do it properly, like with
Yes, sir.
time and effort, and you have to understand it well. So we will be doing complex numbers 6 months down the line or 5 months down the line maybe, and we will be doing it properly. We'll spend 3-4 weeks on it. So right now you're not equipped to do that chapter because you don't know enough trigonometry and many things you don't know. You don't know binomial theorem. How will you do have they done binomial theorem?
No,
No.
sir.
Okay, great. So yeah, so just don't worry about that. Don't spend time working on complex number homework right now when I'm giving you physics and maths homework, right, which is more relevant. Okay.
Yes, sir.
So this question, for example, again, here there is cos and sine and all, right? And here there is sec and all, sec, cosec. I don't care about sec and cosec. I'll convert to cos, right? So convert to cos and sine everywhere. So this becomes 1 by cos square alpha, right? Minus cos square alpha. And this becomes 1 by sine square alpha minus sine square alpha. And on multiplication here, you have cos square and sine square, right? So
Yes, sir.
we have on top, when we do the fraction, we get cos square alpha by 1 minus cos power 4 alpha, plus we have sine square alpha by 1 minus sine power 4 alpha. Okay. And multiplication, we have cos square and sine square alpha, right? Now if you try to do addition here, you will have to deal with these factors, right? This factor and this factor, right? So I will do an addition here. Let's say cos square alpha 1 minus sine power 4 alpha plus sine square alpha 1 minus cos power 4 alpha. And in the denominator, what are my factors? 1 minus cos 4 alpha and 1 minus sine 4 alpha, right? Correct. And on the multiplication, we have cos square alpha sin square alpha. Right? No? Hello?
Yes, sir, I've understood.
So now, right now, remember that I have this factor there on top, and the denominator, I can cancel factors. Can you see how I can cancel factors here? This and this.
Yes, sir.
Why? Because this can be written as 1 minus sin square alpha, right? And this can be written as 1 minus cos square alpha.
Yes.
And this is a square minus b square, where my factors of 1 minus cos power 4 alpha will become 1 minus cos square alpha into
1 plus
1
cos
plus
square.
cos square alpha. So clearly I can cancel this 1 minus cos square alpha, right?
Yes.
With this one, and 1 minus sin square alpha also. And I will end up getting, on top I will get cos square alpha 1 minus sin 4 alpha plus sin square alpha 1 minus cos 4 alpha divided by on denominator I get 1 plus cos square alpha and 1 plus sin square alpha, right?
Yes, sir.
Okay, great. Now if you expand this, right, you will immediately get this. By the way, expand it, 1 plus cos square plus sin square plus sin square cos square, right? And cos square plus sin square becomes 1, so it is 2 plus cos square sin square, right?
So could you repeat that?
Just multiply these two out, you will get this,
Yes, sir. Yes.
because cos square plus sin square will give an extra 1 and it will become 2, right?
Yes, sir.
So denominator is already sorted. We don't have to worry about that. This part is also super easy, because just expand it out. You will get cos square alpha from here and sin square alpha from here, right? And minus cos square alpha sin power 4 alpha minus sin square alpha cos power 4 alpha, right?
Yes, sir.
This is 1 minus, take cos square sin square common, and inside becomes sin square plus cos square, which is 1.
Yes, sir.
So this numerator is also working out, denominator is also working out. All you have to notice in this question is that this one can cancel some factors here. If you don't notice that, then it will be a slightly longer simplification, okay?
Yes, sir.
So like you should be aware enough to cancel factors like this. Then it is over. Like all I have done in these steps is just simply adding it, nothing I've done, okay?
Yes.
Fine.
So how much time should these proof type of questions take? Because some would take me time.
It should take a little bit more than what it is taking me right now.
But
Maybe
some I could do
5-10
in 2-3
minutes.
minutes, but some took me like up to 10 minutes. And
That's
more.
fine. Right now, you're not giving any test. You're not writing any timed test, right? So
Yes.
right now, it's about learning how to do it rather than doing it fast. Just make sure that you're learning how to do it. As long as it takes, you can do it, right?
Yes, sir.
It doesn't matter, time and all doesn't matter right now. What matters is, are you getting the confidence that you can do it, right? That is more important.
Yes.
Any other questions in example 5? Otherwise, we'll move on to the next
No,
exercise.
sir. Example 5.
So the next exercise that I said was, I think, 6 some questions, right? 6 is
Yes,
very
sir.
easy, right?
6 was fine.
Okay, then the next one is which one?
So 10, I think you. Yeah, 10.
Yeah. 1 second. Example number 10 has some. Yeah, example number 10, that is important to be able to do. But this is very easy example.
So
Actually.
10th was also fine.
So actually, let's just do one question. Let's do question 39, prove that types.
So I didn't do from, I think 36 onwards. So I'll need to do it now.
So do it, question 20, 38, 39, let's do.
Yes, sir.
Question 39 is saying prove that cos A plus sine of 270 plus A minus sine of 270 minus A plus cos 180 plus A is equal to 0. Basically, you just have to write things, what this is, and what this is. Okay, so follow the rule that we have learned last class. Tell me when you get what is sine 270 plus a and all. Do you remember how to handle those 270 plus a stuff and all, right? I hope you remember that.
So you had taught how to like find values of like greater than 90 degrees angles.
So that only I'm asking here. Sine 270 plus a. So this angle seems in what quadrant?
Third.
Third. How third? 270 plus something.
Or 270 plus A. Yes, fourth, sir.
So in fourth quadrant, sine should be positive or negative.
Negative.
So the answer should have a negative sign here.
Yes, sir.
And then what will happen? This is even multiple or odd multiples of 90.
Odd.
So sine should become
Cos. So minus cos A.
okay. Okay, so cos a and minus cos a have gotten cancelled, right?
Yes, sir.
And then this minus sign is there, and now look at this 270 minus a. Which angle is it? Which quadrant? Third quadrant.
Third. So, sir, it's minus of minus cos A. I think.
Minus
so,
of
cos
this will again become
A. Cos A.
cos a, right?
So overall is cos A.
Overall is cos a, and this one, think about it is which quadrant is it? Third quadrant again.
Third.
And cos is negative in that quadrant, right? So it will be minus, and will the sign change? Will the cos become a sign, or will it remain the same?
Will remain.
Because it is even multiple of 90.
Yes,
So
sir.
you get cos a minus cos a. So this is identically 0, this expression, right?
Yes, sir.
So the purpose of this exercise 10 is to make sure that you know how to handle these higher than 90 angles, okay? So I am guessing that you know that, so I will not spend too much time on that, okay? So we will go on to the new things that we are going to learn today. Is everything fine in the previous things, last class things?
Yes, sir.
So it's about now you do the questions and you make sure that you remember those things, okay?
Yes,
So
sir.
we'll go on to chapter 6. Chapter 6 says general expressions for all angles. General expression for all angles that have a given trigonometric ratio. That have a given trigonometric ratio. So basically, what does this mean? So what does he mean by this statement? He means that suppose I give you a question like this: sine of x is equal to half, right? Okay. Sine of x is equal to half. So here, what am I giving you? I'm giving you a given trigonometric ratio. No, sine of some angle is half, right?
Yes.
So the trigonometric ratio itself is given to you, and you have to find the general expression for all such angles. You have to find all such x so that sine of x is half, right?
Yes, sir.
So great, all x such that sine of x is half, right? So if I think about it now, one answer is immediately obvious, right? X
Yes.
is equal to pi by 6 or 30 degrees, right?
Yes, sir.
But I also know that some other answers could also come, because what is sine of 180 minus x. Tell me this. What is sine of 180 minus x? Which quadrant is it going to be?
Second.
So it will be plus, because sine is
Yes,
plus
sir.
in second quadrant, right?
Yes, sir.
And angle will not change, so
Remain
it will be
sine.
plus sine x, right?
Yes, sir.
So if I have sine of 30 degree, that should be same as sine of 150 degree, right?
Yes, sir.
So then that means that the equation can be satisfied by x is equal to 150 degrees also, no? It is also satisfied by 150 degree, right?
Yes, sir.
Similarly, if I add 2 pi to pi by 6, so 13 pi by 6, suppose. If I add 360 degree to pi by 6, this is 390 degree. That will also work, no?
Yes, sir.
Because you can keep going on multiple rotations and you'll end up at the same point, right? Correct.
Yes, sir. There are many values.
So there are many values. So similarly, 17 pi by 6 will also fit. So there are infinite values actually. Infinite
Yes, sir.
values of x which will satisfy this equation, right? So solving this trigonometric equation doesn't just mean that you say x is equal to 30 and move on. It means specify all possible values of x. Okay. So now we need some nice way to capture these infinite values. I don't want to keep writing the values. Okay. So if I don't want to keep writing the values, I want to write one particular formula that will contain all of these angles, right? Okay.
Yes, sir.
So to capture all of these angles, you will have to notice some pattern on these angles, right? So here what we saw is 0 plus 30, and then uh, it is 0 plus 150, right? And then it is 2 pi plus 30 and 2 pi plus 150, right? Correct?
So
Are
I
you
didn't get the
understand?
last thing you said.
I'm just saying that the angles here are 30, 150, then it is 390, and then it is 360 plus 150, so 510, right?
Yes, sir.
Okay. So let's think about what formula captures these, right? So you can say that I'm just thinking what formula will capture all of this. I know the answer, so there's nothing else coming to my head. So let's just see this formula. Okay, x is equal to n pi plus minus 1 to the power n pi by 6. So we will discuss it in more detail. Here n is an integer. Okay, n is an integer. N can be any integer. Okay, except 0. N is 1, 2, 3, whatever. Okay. So if you put n is equal to 1 here, x is coming as what? Pi minus pi by 6, right?
Yes, sir.
Correct. Actually, it can be any integer, 0 also. Because if you put 0, you'll get minus 1 to the power 0 pi by 6, right? See, pi minus pi by 6 is 5 pi by 6, no? This one.
So negative is also fine, right?
Anything is fine actually. But negative is just annoying. Just put positive ones. Don't put negative ones. Why do you want to annoy yourself, right?
Yes, sir.
So because minus 1 to the power minus 2, I don't want to handle. I mean, it is 1 only, but fine. I don't want to do the such things. So 0, 1, 2, 3, and so on, right? Any integer like that. So if you put 0, you get 30 degree. If you put 1, you get 150 degree. If you put 2, you get 2 pi plus pi by 6, right?
Yes, sir.
Which is 390 degree. If you put 3 pi, you get 3 pi minus pi by 6. So 540 minus 30 is 510, right?
Yes, sir.
So people basically figured out this formula works in this case. So suppose you have this sin x is equal to half. So what I'm saying is sin x is equal to half. Half can be written as sine of 30 degrees, right? So this equation has become sin x is equal to sine of a known angle, right? And I want to write the general answer for x. So x will be n pi plus minus 1 to the power n into this known angle.
Yes, sir.
Now, if n is any integer 0, 1, 2, you can put and you will get all the possible angles here that fit. Okay. So because notice that whenever n is odd, you get a subtraction here, and when n is even, you get an addition, right? So for n is equal to 0, you get just simply 30 degree. N is equal to 1, you get 180 minus 30, which is 150 degree, the second one. And n is equal to 2 onwards, you got 2 pi minus 30, 2 pi plus 30 and 3 pi minus 30, right?
Yes, sir. So 30 is fixed there, right?
30 is fixed because we know half is sine 30. So this
Yes.
angle is fixed. So pi by 6. So in this case, the answer will be x is equal to n pi plus minus 1 to the power n pi by 6. If
Yeah.
I write in a consistent notation, here I am using pi, I should use pi also here. So this is the general formula. So now if sine C is equal to sine D is my question. Here C is unknown, let's say, and D is known. Okay, D is a known angle. Okay, then then I can write a relation that C will be equal to n pi plus minus 1 to the power n into D. Basically, C can be many angles, right? One
Yes.
obvious angle is C is equal to D, right? When n is 0, C is equal to D comes, right?
Yes, sir.
Correct. Another angle is C is equal to pi minus D. If you put C is equal to pi minus D, see sine 180 minus D will be sine D, right? That comes when n is equal to 1, right? Correct,
Yeah.
you are understanding. Then third one will come 2 pi plus D when n is equal to 2. C is equal to 2 pi plus D and so on, right? So this is the general solution of a sine x equation. When sine x is equal to certain value, right, you can write x is equal to n pi plus minus 1 to the power n sine of whatever that angle was, right? So for example, another example, say sine x is equal to 1. Tell me all possible values of x.
90.
So no, write it like this, sine 90, right? This
Yes.
one can be thought of as sine 90, right? And now use the formula. Don't start listing out the angles. Use the relation that we have just developed. X is equal to n pi plus minus 1 to the power n. 90 can be written as pi by 2, right?
Yes, sir.
Now here if you put n is equal to 0, you get the 90-degree angle, right?
Yes,
Put
sir.
n is equal to 1, if you put, what do you get? Pi minus pi by 2, which is again 90-degree angle only, right?
Yes, sir.
N is equal to 2, you get 2 pi plus pi by 2, right? Which is basically 450 degree, right? Correct.
Yes, sir.
And so on. So you will get many angles here. Those will be the answers for this. Suppose I gave you this question instead. Sin x is equal to 1 by 3. Now what will you do? What is x now? See, all of these questions that we saw earlier, half, 1, the reason you were writing it like this was because you knew what the angle was which was make sine 91, right? Or sine 30 half, right?
Yes, sir.
Right now, I don't know what angle will make this 1 by 3, right? Sine. I don't know that angle, no?
Yes,
D. What is the D that makes it 1 by 3, right? If I knew that D, then I would have written what? X is equal to n pi plus minus 1 to the power n into D, right?
yes, sir.
Are you understanding what I'm saying?
This was if D was known or not.
If D was known, then I would have written the answer like this, no?
Yes, sir.
But D is still known. It's just that we don't know the value, but it is a fixed value, no? 1 by 3 it is. Sine D is 1 by 3, right?
Yes, sir.
So generally when you don't know the value must be in some table, right? Trigonometric tables are there where you can find out, right?
Yes, sir.
So we will write that value of d. D can be written as sine inverse of 1 by 3. What does this mean? This is just a notation to say that D is such an angle whose sine is 1 by 3. Okay. This is just a
So could you
notation.
repeat that?
What have you heard?
So you said if D is not known, you can write it this way, and this is just a notation.
And why? What is the notation conveying? The notation is saying
Sine
that,
inverse 1 by 3.
I mean, what does that notation mean? The notation means that D is whatever angle whose sine is 1 by 3. If someone gives you this question, sine D is equal to 1 by 3, find D, then what is your only option right now? What is the option to find D? You will look at a table, right? Look at a
Yes, sir.
trigonometric table or look at a calculator and stuff, right?
Yes, sir.
But if you look at it, you will find the answer there. No, it was not some unknown stuff, because sine of it is known, then that should be known, right?
Yes, sir.
It's just that you don't know the value in your head. So for now, for the purpose of the problem, you will write it as D is the angle sine inverse 1 by 3.
So what does that signify?
Whatever angle comes when you look at the table. That signifies that D is an angle whose sine is 1 by 3. What else will it signify?
So why is the sine inverse?
There is a sine inverse because uh, when you do a function, when you take a function, if you take a sine on this function, sine of D, you should get sine of sine inverse. So these are two different operations which cancel each other. So it is 1 by 3. Like, for example, if I say y is equal to x square is my function, and for x is equal to 4, y is equal to 16. So if I have to find x from here, what will you do if you have to find x from here?
From where?
Y is equal to x square. If you have to find x, what is x?
Root y.
So why did you write it like this? What does this signify?
It's basically like basically making x like in terms of y. So just like
No.
rooting on both
So
sides.
if you had y is equal to x square, why did you write it like this? What is this symbol signify?
Like -1, like inverse basically. To the power -2.
To the power? This is to the power what? This signifies half, no?
Yes, sir.
So you are doing the opposite operation.
Yes, sir.
Here you were doing x square, now you're doing x power half, right? You're doing some way, you are reversing this operation, no?
Yes, sir.
The same thing is signified here. Like if y is equal to sine x,
Okay,
x
yes,
will
I
be
got it.
equal to sine inverse of y. Basically, you are saying, basically, what are we signifying here? The x root x is the number. If you square it, you will get y,
Yes,
right?
yes, I got it.
Are you sure you got it?
Yes, I have understood.
Sine inverse is just a symbol that says it is such an, if I say, suppose y is equal to sine inverse x, suppose I say, right? So this means that y is such an angle whose sine is x. Y is such an angle whose sine is x. So if you take sine on both sides, sine and sine inverse will cancel each other, right?
Yes, sir.
So it will become x only. So for example, if I do square on both sides, right? Square and root operation will cancel each other and become x, right?
Yes, sir.
Because the square and root operations are opposites of each other, inverse of each other. So that's all that it signifies.
Yes, I got
So
it.
if you have sine x is equal to 1 by 3, I don't know what 1 by 3 is, which angle will give sine of 1 by 3, right? So I will just say that, okay, great. This must be sine of something, right? Some d. I don't know what
Yes,
it is, but it will be sine of some d. So if I knew the d, my answer would have been what? N pi plus minus 1 to the power n d, right?
yes, sir.
So now my answer will be x is equal to n pi plus minus 1 to the power n into d is sine inverse 1 by 3, right? So I'm just saying I don't know it, but it must be some constant value, right?
Yes, sir.
So that is the general solution of a sin x is equal to sin some value type of an equation. Sin x is given, the trigonometric ratio is given to be some fixed quantity p. Then your general solution becomes x is equal to n pi plus minus 1 to the power n sine inverse of p. If my p was nice values for which you know the angle, then I don't need to write it like this, right?
Yes, sir.
So if
So
it
this is
is
only if you don't know it, right?
only if you don't know it, you have to write it. Otherwise, you already know it. So you'll not write this, you'll write the angle, right?
Yes, sir.
So similarly, now we'll look at equations like this. Cos x is equal to half, for example. Here, I know that it is cos 60, right? I know this value, right? So one answer should be x is equal to 60. There are possibly other answers also, right?
Yes, sir.
So let's look at when is cos positive. So cos is positive in first quadrant and fourth quadrant, right? Correct.
Yes, sir.
So half value of cos can come once in first and once in fourth quadrant, right? So
Yes, sir.
there is a possible angle in the fourth quadrant for which this will still be fine, right? It will be half, right?
Yes, sir.
So I will try this angle 270 plus. Okay, so 270 will not work because 270 will change it, right? Will change it to sine, no? Correct. You
Yes, sir.
understand? So let me see this one 270 plus 30 degree. Let's see that what happens. Cos 270 plus 30. First of all, I notice the sign that it is a cos of a fourth quadrant angle, right? So it will be plus, right?
Yes, sir.
And then the next step is to think about since it is plus, now it will change the sign, no? So it will be plus sine 30, right?
Yes, sir.
But notice that that is half, right?
Yes, sir.
So there is an angle that you have found 300 degree, right? Which
Yes,
is
sir.
fitting the same value, right? So 60 degree and 300 degree is another angle, correct?
Yes, sir.
And now there are many such more angles because you can add 360 degree to 60 degree and it will end up being at the same point on the circle, no?
Yes, sir.
So 420 degree should work and 660 degree should work, no? 360 plus 300, right?
Yes, sir.
And so on. Many infinite angles are possible, right? So now we can construct a general formula for this also. Okay. So just like we got n pi plus minus 1 to the power n into x d, right? For sine. We can
Yes.
construct a general formula for this also. Here we can write x is equal to 2n pi plus minus d. So for example, here you have cos x is equal to cos d, suppose. Cos x is equal to cos d was my equation. I'm saying the answer will be x is equal to 2n pi plus minus d. So what are the possible values that you will get here? Let's see, n is equal to 0. N is equal to 0. X is coming as plus minus d, no? Right?
Yes, sir.
X is coming as plus minus d. So notice that plus minus 60 degree both will satisfy. Cos of minus 60 is the same. Why? Is the same as cos of 60 degree because earlier in the last class we had discussed that when you go to the negative side, this is the angle, right? Cos of minus 60, right? Correct? For
Yes.
minus 60, basically you have to go in the clockwise direction from x-axis, no?
Yes, sir. Yes, sir.
So think about it, minus 60 is the same way as going plus 300 from this side, no?
Yes, sir.
So cos of minus 60 will be same as cos of 300, which is same as half, right?
Yes.
So x is equal to plus minus d comes when you put n is equal to 0. And n is equal to 1 if I put, what do you get? X is equal to 2 pi plus minus d, right?
Yes, sir.
Now notice here D was 60 degree here. So 2 pi minus 60 is 300, 2 pi plus 60 is 420, right?
Yes, sir.
Basically what I'm saying is the solutions of this are coming as 0 plus minus 60, 360 plus minus 60, then 4 pi. So 720 plus minus 60. See, 720 minus 60 is 660, right? 720 plus 60, the next one will be 780, right?
Yes, sir.
So this formula now captures all our results for cos x equations. So what
When
am I
D is
saying?
known, right?
Huh? What?
When D is known.
Huh? That, yeah. When D is known, obviously. Otherwise, you write it as cos inverse, whatever. So
So can you
here,
write that once?
here it is like this: 2n pi plus minus D. So if D is known and C is unknown, if it is an equation like this, cos x is equal to some p, then you will write x is equal to 2n pi plus minus cos inverse p, whatever it is. If it is some nice value of p where you know the angle, then you don't need to do this,
Yes.
right? If it is on not some nice value, then you will have to write it like this. Correct?
Yes, sir. Yes, sir.
So that is my cos x equation. And similarly, now we can do the tan x equation also. Tan x is equal to, let's say, 1 by root 3, right? So normally, let's guess some values. This is obviously 30 degrees a value, right? And
Yes.
you know that tan is positive in which quadrant? Third.
Third and first.
So if I do 180 plus 30, what is coming? Let's see. So tan is positive, so plus answer will come, and tan ratio will not change, because it is
Yes, sir.
even multiple. So it will be
Tan
plus
30.
30 only. So that will be also root 3. So the other possible angles are 210 degree, right?
Yes, sir.
And then you add 180 to it, 360 to it. So 390 should also work, right? And
Yes.
360 to it, so 570 should also work, and so on, right? You'll get any infinite angles, right? So the formula for tan is x is equal to n pi plus d, where d is that known angle, where n can be any integer 0, 1, 2, start putting any values. So if you put 0, what does it become? Just 30. Here d is equal to 30. And if you put 1, what does it become? Pi plus 30, right? Which is 210,
Yes,
right?
sir.
And if you put 2, it is 2 pi plus 30, which is 360 plus 30 or 390. And then it is 3 pi plus 30, which is 570, 540 plus 30. Correct. So the formula for tan, if your equation was like this, tan x is equal to tan d, you'll get x is equal to n pi plus d. Here d is a known angle. If your equation was some tan x is equal to some value, then we'll just write x is equal to n pi plus cos tan inverse p. If the value of p is not nice so that you don't know the angle, then you can write it like this, right?
Yes, sir.
Correct. So basically, this chapter is helping you predict what are the possible angles for which the trigonometric ratio will be some particular value, right? What are the
Yes.
possible angles? Let's look at some questions right now. We have to do now in this one exercise 11 and exercise 12. Okay, so let's look at some questions from these two exercises. Exercise 11 and exercise 12. Okay, so exercise 11, let's look at question number, say, 15. Question number 15 in exercise 11. So that is 4 sine square theta is equal to 3. Okay. The question is asking you to find out the general values of theta. All possible general values of theta. Okay. Today is Friday, right?
Yes, sir.
Okay. Fine, fine. Okay. So how do I go about doing this, right? So first of all, what we'll do is sine square theta is equal to 3 by 4, right? So
Yes.
first of all, I get again sine theta could be either root 3 by 2 or it could be minus root 3 by 2, right? Correct.
Yes, sir.
So there are two possible solutions. So let's do two possible sets of answers, right? You could have one set of answers for this, right? And one set of answers for this.
Yes, sir.
So let's write our set of answers for this. This angle, this value is nice. I know the angle, right? 60 degree.
Yes, sir.
So I will just write theta is equal to n pi plus minus 1 to the power n pi by 3, which is 60, right? This is my sine formula, by the way. I'm
Yes.
using the sine formula. Okay. Then here this minus root 3 by 2, I can write that this probably is a nice angle, but I have to figure out what that angle is, right?
Yes, sir.
Correct. So there are multiple ways to do it. There is one way to do it, which is saying sine 180 degree plus theta. What is that? Think about it. That will come out to be minus sine theta, right?
Yes, sir.
So sine of 240 degree will be equal to minus sine 60 then, right? Which will be minus root 3 by 2.
Yes, sir.
So you could put angle theta as 240 degree, right? Here, correct?
Yes, sir.
But ideally, I don't want to put my theta as a very big angle. I want it to be an acute angle only, right? Because so far we have been using acute angles whenever we talk about this sine 180 plus theta, right? We
Yes.
think of theta as acute, right? So I don't want to use this 240. I will use the fact that sine of minus 60 will be equal to minus sine 60 will be equal to minus root 3 by 2. So here basically I'm saying theta can be written as minus 60 degree. Why am I saying that? Let's think about it using the graph that we had, right? The circle thing, right? So what is minus 60 degree? You have to go in the clockwise direction, no?
Yes, sir.
This is your minus 60 degree angle, right? So you have gone 60 degree in the clockwise direction instead of anti-clockwise as usual, right?
Yes, sir. So it's minus.
So it's minus 60. So if I wanted to reach this same point in the anti-clockwise way, how much angle do I have to go?
300.
300 degree, right? So what I know for sure is that sine of minus 60 is same as sine of 300, right? Correct?
Yes, sir.
So now you can convince yourself that sine 300 I can find directly. No? There is no issue. I can find sine 300 as sine of 270 plus 30, right?
Yes, sir.
So let's do that. First of all, sine 300 is a fourth quadrant angle, so answer should be negative, right?
Yes, sir.
And it should be minus cos 30
Minus
now,
cos.
right? Right?
Yes, sir.
Which is minus root 3 by 2, right?
Yes, sir.
So I have convinced myself that sine of minus theta is equal to minus of sine theta, right? This is minus sine 60 also, by the way. Right?
Yes.
So that's why I will use theta as minus 60 here, which is a acute angle at least. It will be fine if you can use 240 degrees also possible, but generally you write using small angles, right?
Yes, sir.
So the other formula for this one, the formula will be theta. The general answer will be n pi plus minus 1 to the power n minus pi by 3, right?
Yes, sir.
So the overall answer is basically the combination of this and this. Okay. So all of the angles which satisfy those relations will come into the answer, right? Every angle that satisfies this condition and that condition will be an answer.
Yes, sir.
So you can check some values and get all possible answers now. You can put n is equal to 0, 1, 2, and so on, right?
Yes.
But this is the general way that you solve this question. Let's look at some more examples. Okay, the next one that I want to look at is 16th one. Okay, 16th one. 16th one is saying 2 cot square theta 2 cot square theta is equal to cosec square theta. And what do I have to find? I have to find all possible values of theta. This is an equation in theta, okay? All possible values of theta we have to find here. So what is the first thing that comes to your head here? It is cot square and cosec square. So is there an identity that you remember? Hello?
Hello, can you hear me, sir?
Yeah. So
Oh,
what
yes,
is the
sir.
identity? Cosec square is?
1 plus cot square theta.
Okay. So that becomes this cot square theta is this. So you get simply cot square theta is equal to 1, right? So cot theta could be plus or minus 1, right?
Yes, sir.
So I don't know a general answer for cot theta, but I know a general answer for tan theta, right? So I'll write tan theta is plus or minus 1 here. If cot theta is plus or minus 1, obviously tan theta is also plus or minus 1, no?
Yes, sir.
So my possible answers are the answers which come from this and the answers which come from this, right? These are the possible angles that will satisfy this equation, right? Correct. Hello?
So could you repeat that once? The last part.
The angles that come from tan theta is 1 and tan theta is minus 1 will satisfy this equation, no?
Yes, sir.
What is the general answer for this one? Theta will be equal to tan. General solution was what? General solution was n pi plus whatever angle, right?
Yes, sir. N
So
pi plus t.
what is the angle here?
45. So
Pi
uh,
by 4.
pi by 4. Yes, sir.
And here theta will be equal to n pi plus minus pi by 4. You can convince yourself that if you have a negative tan of minus theta is equal to minus of tan theta is equal to, if it was pi by 4, it will become minus 1, right? Minus pi by 4. Why is that so? Tan of minus theta, go theta distance in this direction, right? This is your minus theta angle, no?
Yes, sir.
So again, think of it like this. Like this, it is basically how much? 360 minus theta, right?
Yes, sir.
360 minus theta is the clockwise, anti-clockwise angle, right? So tan of minus theta is the same as tan of 360 minus theta, right?
Yes.
And this is a fourth quadrant thing, right? So fourth quadrant tan is negative. So minus tan theta, right? Because the angle also tan ratio doesn't change here. It's even a multiple of 90.
Yes.
So that proves that minus tan theta is same as tan of minus theta. So therefore my minus pi by 4 will work here, right?
Yes, sir. But for cos and sec, it's positive only, right?
Cos and sec and all it is positive. Sin and tan it becomes negative.
Yes.
So the other answer basically comes as tan n pi minus pi by 4. Theta is equal to n pi minus pi by 4 or plus n pi plus pi by 4. Both of them are possible solutions.
Yes.
Correct. So that is the answer for this. Now I want you to try exercise 11 properly. Okay. So there will be difficult questions, slightly more difficult questions here, but I want you to try it because this will help you understand this whole trigonometric equations part really well. Let's move. We will move on to right now exercise 12 and do some questions in 12 so that you can attempt that as well.
Yes, sir.
Exercise 12. So let's look at question number 17. Question number 17. Okay, actually before 17, I will do one of these other types also. So for example, question number 6, let's do. Question number 6 says this: sine square theta minus cos theta 2 cos theta plus 1 by 4 is equal to 0, right? You have to find the general theta that satisfies this, correct? The question is still the same. Solve the equation. Basically, find the general angle that satisfies this. Right?
Yes.
So obviously, this looks like a quadratic in sign, right? So I can easily convert it into cos square, right? Then it will be a quadratic in cos.
Yes, sir.
So I'll write 1 minus cos square theta minus 2 cos theta
Plus 1 by.
is equal to 0. So this will, after simplification, become cos square theta plus 2 cos theta minus 5 by 4 is equal to 0, right?
Yes, sir.
Okay, great. Now we have to solve this equation. So this is a simple quadratic in cos theta, which I can solve. I can directly use the formula. That is also not going to be so hard. So it will become minus 2 plus minus b square is 4 minus minus plus 5. 4ac will become 5 by 2. So this becomes cos theta is minus 2 plus minus 3 by 2. So cos theta could be 1 by 2 or it could be minus 5 by 2, right?
Yes, sir.
Now, which answer is possible? Obviously, minus 5 by 2 is impossible. Cos theta should be between minus 1 and 1, no?
Yes, sir.
So this is minus 2.5, right?
Yes.
So this is a rejected solution. This is not a real solution. This is the possible answer, right? So you're getting this equation has roots cos theta is equal to half, right?
Yes, sir.
And now obviously I know my cos formula, so theta will become 2n pi plus minus whatever is this angle, but this angle is easy, it's pi by 2, right?
Yes, sir.
If it was some unknown angle, I would have written it as cos inverse of that 1 by 2 or 1 by 3.
So we can leave it in terms of cos inverse.
No, if you know the angle, you should write it as an
No, no,
angle.
if you don't know.
Yeah, obviously. You don't know, you don't have tables and all in your hand, no, all the time.
Yes, sir.
So then you'll just write it as cos inverse, whatever. Right?
Yes, sir.
Okay. So basically, the idea here was get a quadratic, get a value for cos. Once it comes like this, solve
Anything.
using the new knowledge that you have, right?
Yes, sir.
Find the general solutions. Okay. So this is just a slightly more advanced question. In the earlier exercise, the questions were directly giving you this, right?
Yes, sir.
Now it is, you have to do some effort to get the answer. Cos theta is what, right? After that, you have to apply the
Same.
general solution, right?
Yes.
Okay. Question 17, let's see. Question 17 is saying sine of 9 theta is equal to sine of theta, right? And you have to find all possible theta, right? Values of theta.
Yes.
Okay. So right now here doesn't it already look like it is an equation like in the form sine c is equal to sine d, right?
Yes, sir.
It already looks like it is in the right form, no? So if it was like this, I would have written c is equal to n pi plus minus 1 to the power n into d, no? Correct?
Yes, sir. Yes.
So here directly you can write that, right? You can write 9 theta should be equal to n pi plus minus 1 to the power n into theta, right? C is 9 theta, D is theta,
Yes, sir.
right? So now it is still not solved because we have to find theta, right? So
Yes, sir.
here there is a sign change depending on whether n is even or odd. So I will take two cases. Take two cases. Case one, n is even, right? N is even, then n can be written as 2k, right? Some integer 2k.
Yes, sir.
So you will get 9 theta is equal to 2k pi plus theta.
Yes, sir.
So you will get 8 theta is equal to 2k pi. So theta should be k pi by 4, right? Where k is any integer.
Yes, sir.
So this is one set of values that I'm getting, and I will do case 2, where n is equal to 2k plus 1. Basically, it is odd now, right?
Yes, sir.
Correct? you'll get 9 theta is equal to 2k plus 1 pi minus theta in this case. So you'll get 10 theta is equal to 2k plus 1 pi. So you'll get theta is also possible that it could be 2k plus 1 pi by 10, right? K is any integer.
Yes.
You understand what has happened? Initially, already it is in the correct form where you can apply a result like c is equal to n pi plus minus 1 to the power n into t, right?
Yes, sir, but it's not given.
But it's not known. Theta is not known, and that is your job to find theta. So I have to just simplify it in two ways because n could take plus or minus. So I have to take both the cases and do it properly, right? So I'm taking n as an even number once and n as an odd number another time, right?
Yes.
And that will give me the possible values of theta. So you can get 8 theta is 2k pi or 10 theta is 2k plus 1, right? Correct.
Yes, sir.
Let's look at now question number 20. Question number 20. Question 20 is a slight twist on this. It is saying sine 2 theta is equal to cos of 3 theta, right? Sine 2 theta is equal to cos of 3 theta. Now directly I cannot apply any formula here. If you think about it, you don't have any formulas for situations like this, no? Sine x is equal to cos y.
Yes, sir.
It is either a sine x is equal to sine y situation or a cos x is equal to cos y situation, right? Then you have the general results, right? You understand what I'm saying?
Yes, sir.
You don't have any formula for sine x is equal to cos y. Here, this is what is happening. Sine something is equal to cos something, right?
Yes, sir.
So what can you do now? How will you handle this? There is a way to do this even now. Okay. So what you can do is, in order to be able to use some result, I need to convert it into an either sine or an either cos equation, right?
Yes, sir.
So we can easily say that I can convert cos to sine. That is not an issue for me. I know complementary angles and all. No?
Yes, sir.
I know sine of 90 minus theta is equal to cos theta, right?
Yes, sir.
So I can write this as sine of 90 minus 3 theta, right?
Yes, sir.
So now it is becoming in the correct form where you can apply a formula, right?
Yes, sir.
Sine 2 theta is equal to sine of 90 minus 3 theta, right? So now I will say 2 theta should be n pi plus minus 1 to the power n pi by 2 minus 3 theta, right? Correct? Because it is in the right form, sine x is equal to sine y,
Yes, sir.
right? Okay, great. But right now, still my theta is not known because it is inside here also, no?
Yes, sir.
So what will I do? I'll take two cases. N is equal to 2k for even and n is equal to 2k plus 1 for odd, right? So that the
Yes.
sign can be two different cases, right? So if it is even, I'll get 2 theta is equal to 2k pi plus pi by 2 minus 3 theta, right? So you get 5 theta is equal to 2k pi plus pi by 2, and theta becomes 4k plus 1 pi by 10. After simplifying, you can do it, right?
Yes, sir.
You understand what I have done here? Theta is here, k is any integer, right?
Yes, sir. Yes.
In case it was odd, it would have gotten like this. 2 theta is equal to 2k plus 1 pi minus pi by 2 plus 3 theta, right? So you'd
Yes.
get theta is equal to pi by 2 minus 2k plus 1 pi after simplifying. K can be any integer here. Okay.
Yes, sir.
Okay. Let's try to solve now. This time you have to try it. Okay. So question number 26.
26.
Question 26 is saying tan theta is equal to 1. Solve for theta, all possible values. Are you getting any ideas? What are you trying?
So tan theta is 1 by tan 2 theta.
Okay, so tan theta is 1 by tan 2 theta. 1 by tan 2 theta can be written as what? What do you say this?
Cot 2 theta.
And cot can be converted to tan. I mean, complementary angles, tan becomes cot, no?
Yes, sir. Yes.
So this can be written as 90 minus 2 theta.
Okay. Yes, sir.
Then you have the thing in the correct way to write, right? Now you have it in the proper form. Tan x is equal to tan y. That is my form when I have the general result, right? You have x is equal to n pi plus y. Okay. You are getting what I'm saying, no?
Yes, I've understood.
So this will be written as x is equal to n pi plus pi by 2 minus 2 theta. So then you can get 3 theta is equal to n pi plus pi by 2. So therefore theta will become n pi by 3 plus pi by 6, where n can be any integer. That is the answer. So I hope you are getting the idea here, what has to happen, right? There are some more difficult ones, but I want you to try them before I tell you how to do it. Okay.
Yes, sir.
So exercise 11 and exercise 12 will be your homework for this week. I was thinking of starting the next chapter, but I think already this is fairly enough. So in the next week's class, however, we'll do chapter 7 and chapter 8. Okay. So I want you to attempt all of the questions in this exercise 11 and 12 as much as you can.
Yes, sir.
And especially exercise 12 till question number 35. Okay. Question till question 35. If you can solve till question 35 of exercise 12, 1 to 35, then you have understood the chapter.
Yes.
So you can check the answers at the back of the book, but this should be sufficient. Uh, Focus on this part. Don't worry about whatever is going on in Allen. Anyway, it is not very useful. Right now, they're not teaching the right things. They will teach complex numbers now. Then next, I don't know what they will teach. Maybe they'll teach some calculus after that and coordinate geometry after that. But
So in physics and chem, I think they're going fairly the same chapters.
But maths, what are they
Physics,
doing?
calculus is there. In chem, they were doing like periodic table and
That's fine. But in maths, they should not be doing complex numbers.
yes,
They should be doing trigonometry. I don't know why they're not doing it. Anyway, focus on this part. Make sure that you do the homework now.
yes,
Tomorrow we'll do the physics class. Okay.
yes,
Physics. Last week we were doing a little bit of calculus. I hope you have seen some of the differential calculus stuff from Thomas and Finney.
yes. So you gave those 3 chapters.
Yeah. So we'll discuss a little bit more of differential calculus and then we'll move on to integral calculus from there. Okay.
Okay, yes.
Okay. That's all for now then. I'll see you tomorrow.
Thank you, sir.
Bye.
Bye.